What if your smartphone could repair its own shattered screen? What if your clothes could charge it just as you walk? Sounds like a scene pulled straight from a science fiction movie, doesn't it? But what if I told you this isn't fiction at all? It's a reality being unlocked right now, thanks to incredible new materials. Today, in labs across the globe, scientists are engineering substances with properties that just yesterday felt like pure magic. In this video, we're going to dive into 20 such materials, substances ready to completely revolutionize our world. Prepare to be amazed, because the future is much closer than you think. Since ancient times, the progress of human civilization has been inherently tied to the materials we use. Just consider the Stone Age, the Bronze Age, the Iron Age. Each new material ushered in a new epoch, providing new tools, new opportunities, and fundamentally changing the course of history. Today, however, we stand not on the verge of one such era, but several simultaneously. Thanks to massive breakthroughs in physics, chemistry, and nanotechnology, we have moved beyond simply finding materials in nature. We can now design and create them at the atomic level. We can tailor their properties exactly as needed, making them ultra-strong, incredibly light, self-healing, or perhaps even invisible. Let's take a look now at these true marvels of engineering. Let's start with the real superstar of the materials world, graphene. Imagine a sheet just one atom thick. That's right, a single atom. Yet it's 200 times stronger than steel, and it conducts electricity better than copper. It's like taking a regular pencil, pulling out the graphite and stretching just one layer of it over an entire football field. Sounds unbelievable, doesn't it? Scientists Andrei Geim and Konstantin Novoselov won the Nobel Prize for its discovery, and for good reason. Graphene's applications are virtually limitless, from ultra-fast processors and flexible transparent screens to super batteries that charge in mere seconds. And that's not all. You can also use it to create filters capable of desalinating seawater with almost no energy cost. This is a material that genuinely has the potential to solve dozens of global problems. Visual, an animation showing graphene's hexagonal lattice stretching over a globe, followed by shots of a flexible smartphone and a futuristic battery. Next up is aerogel, famously known as frozen smoke. And this name is well deserved. Aerogel is 99.8% air, making it the lightest solid material on the planet. A piece of aerogel the size of a human would weigh less than a bag of chips. But don't let its airy nature fool you. It can support thousands of times its own weight. Its main claim to fame is its phenomenal thermal insulation. A thin layer of aerogel protects against extreme heat and cold better than a thick wall of fiberglass. NASA already uses it to insulate Mars rovers and to collect cosmic dust. In the future, it could appear in our homes, making them super energy efficient, and in our clothing, protecting us from even the harshest frost. Visual, an almost invisible piece of aerogel rests on a flower, followed by a heavy kettlebell placed on top of it, then a shot where a burner flame fails to penetrate a thin layer of the material. But what about a genuine invisibility cloak? This is the realm of metamaterials. Unlike conventional substances, their properties are defined less by chemical composition and more by their artificially engineered microscopic structure. These structures are so minuscule, they can manipulate electromagnetic waves, including visible light, sound, and radio signals. Put simply, a metamaterial can force light to bend around an object, just like water flows around a rock in a stream. The result is that the object becomes completely invisible to the observer. Currently, a true full invisibility cloak is confined to laboratories and only operates within a narrow wave spectrum. But this technology is developing rapidly. Beyond invisibility, metamaterials can be used to create super lenses capable of seeing objects the size of a virus, or even for protecting buildings from earthquakes by deflecting seismic waves. Visual, animation, showing light rays smoothly bending around a sphere, rendering it invisible. Cracks in concrete have always been a massive headache for the construction industry, But what if concrete could heal itself? Well, that's exactly what self-healing concrete achieves. The secret lies in special microcapsules added directly to the concrete mix. Inside these capsules are specific bacteria and the nutrients they need. While the concrete is intact, the bacteria lie dormant. But the moment a crack appears and water penetrates it, the capsules rupture. The bacteria wake up, begin feeding rapidly, and during this metabolic process, they secrete limestone. This limestone fills the void, making the structure monolithic once more. The entire process mimics how a wound heals on the human body. This innovation could significantly extend the lifespan of bridges, buildings and roads, saving billions in repair costs and dramatically improving infrastructure safety. Visual, time-lapse footage showing a crack in a concrete block gradually healing and disappearing. Imagine a metal that actually floats on water. It's not magic, it's called metal foam. Essentially, this is a standard metal, like aluminum or steel, infused with thousands of tiny gas bubbles. The result is a material that maintains the incredible strength of solid metal, but becomes unbelievably lightweight. Metal foam boasts a unique combination of properties. It excels at absorbing impact energy, dampening vibrations, and blocking sound. This makes it an ideal candidate for the automotive industry. Using this foam in bumpers and body panels could drastically improve safety in crashes. Beyond cars, it has immense potential in construction for lightweight, durable panels, in aerospace, and even in medicine for creating advanced implants. This is because its porous structure closely mimics that of natural human bone. Visual cue: a block of metal foam floats effortlessly in a tank of water, followed by slow-motion footage of a hammer striking the foam, which compresses and absorbs the entire impact. Have you ever seen a piece of crumpled metal return to its original shape all by itself? That's what shape memory alloys do. The most famous example is nitinol, an alloy of nickel and titanium. This material has the astonishing ability to remember its initial configuration. You can deform it, bend it or twist it when it's cold, but apply just a little heat, and it instantly reverts to its stored or remembered configuration. This property has already found critical applications in medicine. For example, vascular stents used to widen blood vessels are made from nitinol. They are inserted into the artery in a compressed state, and the warmth of the human body causes them to deploy and take on the necessary shape. In the future, these alloys could be used in aircraft with wings that change shape during flight, or in cars that can literally pop out dents after minor collisions. Visual: a heavily bent nitinol wire is dropped into hot water, instantly straightening itself. Our bodies, engines and computers all generate vast amounts of heat that are simply wasted. But what if we could turn that heat into usable energy? That's exactly what thermoelectric materials are designed for. They operate using the Seebeck effect. By heating one side of the material while keeping the other cool, an electrical voltage is generated between them. Essentially, they directly convert a temperature differential into electricity. Even today, we have camping gadgets that allow you to charge your phone simply using the heat from a campfire. In the future, these materials could coat car exhaust pipes, recovering wasted engine energy, or they might even be woven into clothing, using our body heat to power wearable electronics. This represents a genuine breakthrough in energy conservation and alternative power generation. Visual: a small generator placed on a hot mug powers an LED, followed by an animation of a car, where heat from the exhaust system powers the onboard electronics. We all know the famous sight: water droplets rolling right off a lotus leaf, leaving the surface perfectly dry and clean. This is the famous lotus effect, and now scientists are trying to replicate it using super hydrophobic materials. These surfaces feature a unique nanostructure that actively resists being wetted by water. Essentially, the water droplets rest on the very tips of microscopic pillars or fibres. This keeps them perfectly spherical, causing them to roll off with the slightest incline, capturing dust and dirt particles along the way, a process known as self-cleaning. The potential applications for this technology are massive. Just picture clothing and footwear that never get soaked or stained, Or imagine cars that simply don't need to be washed. Beyond that, these coatings can prevent dangerous icing on aircraft and power lines, provide essential moisture protection for sensitive electronics, and even reduce drag on ship hulls, making vessels significantly faster and more fuel efficient. Visual cue. Watch the slow motion footage as the water bounces off this treated fabric like tiny rubber balls, and see the dirt just wash away without leaving any residue. Remember that Star Trek movie where Scotty talked about transparent aluminum? Well, it turns out it's real. Officially, it's called aluminum oxynitride, or ALON. This material is a transparent ceramic that offers optical clarity almost identical to glass, but boasts strength that far surpasses many conventional types of armour plating. A sheet of ALON, just 1.5 inches thick, that's about 4 centimetres, is tough enough to stop a .50 caliber armour-piercing round. Crucially, it is significantly lighter than traditional laminated bulletproof glass. Currently, the high cost of production means ALON is primarily restricted to military applications, protecting sensitive tank optics, missile sensors, and crafting high-security bulletproof windows. But as the technology matures and production costs drop, we might eventually see it used for truly unbreakable smartphone screens or in the structural windows of modern skyscrapers. Visual cue shows slow-motion footage of a bullet hitting the ALON panel. The bullet flattens and ricochets, leaving only a minor crack. If graphene is a flat sheet of carbon atoms, carbon nanotubes are essentially that same sheet, rolled up into a microscopic cylinder. These tiny structures boast truly remarkable characteristics. They are tens of times stronger than steel, yet weigh 6 times less. Their tensile strength is so immense that, theoretically, you could weave a cable strong enough to reach orbit, the very space elevator long dreamed of by science fiction writers. Furthermore, depending on their structure, nanotubes can function as both conductors and semiconductors, making them ideal candidates for replacing silicon in microchips. They could also form the basis for artificial muscles, supersensitive sensors, and even targeted drug delivery systems that zero in directly on cancer cells. The term liquid metal might immediately bring to mind the T-1000 Terminator, but the real thing, while different, is arguably just as fascinating. We're talking about amorphous metals. Unlike conventional metals, which have an ordered crystalline structure, amorphous metals have atoms arranged chaotically, like in a liquid or glass. This unique structure eliminates the weak points inherent in crystals, granting them extraordinary properties. They are far stronger and more elastic than their crystalline counterparts and highly resistant to corrosion and wear. These materials are already being used to create casings for high-end smartphones and watches, as well as sports equipment like premium golf clubs and tennis rackets. In the future, they could be used to create truly non-wearing blades, long-lasting medical implants, and significantly more efficient electric motors. Visual cue description. Consider this comparative test. Drop 2 metal spheres, one steel, the other made of an amorphous alloy, onto a hard surface. The amorphous sphere will bounce back significantly higher, clearly demonstrating its superior elasticity. Plastic pollution is one of the major environmental challenges of our time. One potential solution is bioplastics derived from algae. Algae makes for an ideal raw material. They grow fast, they don't require fertile land or fresh water, and crucially, they absorb carbon dioxide from the atmosphere as they grow. Various technologies exist to convert algae into plastic. Some of these methods allow us to create completely biodegradable material, which breaks down in compost within months, turning back into fertilizer. Other technologies produce plastic that is chemically identical to conventional plastic, but is sourced entirely from a renewable resource. This type of plastic is already being used to manufacture bottles, packaging, and even automotive parts. This is an excellent example of how nature can help us solve the very problems we created ourselves. Visual suggestion. Green algae farms followed by the processing sequence. Final shot. A plastic bottle, shown in time-lapse, decomposing into a handful of soil. Spider silk is truly one of nature's most astonishing creations. Pound for pound, It's 5 times stronger than steel, yet remains incredibly elastic. The challenge, however, is that farming or milking spiders on an industrial scale is impossible. They are highly territorial cannibals and simply cannot be kept together. For decades, scientists have been working tirelessly to create a synthetic analogue, and they are finally making breakthroughs. Using genetic engineering, they have successfully compelled bacteria, yeast, and even silkworms to produce the fundamental spider silk protein. This protein is then spun into fibres with properties remarkably close to the natural material. The potential applications for this material are enormous, everything from ultra-strong, lightweight body armour and dissolvable surgical sutures to bridge suspension cables and next-generation athletic wear. This is a perfect example of how biomimicry, the process of imitating nature, drives true technological breakthroughs. Imagine a material capable of moving entirely on its own, contracting and expanding just like a living muscle. This is exactly what electroactive polymers are. These smart materials change their shape or size when exposed to an electric field, remove the voltage, and they spring right back to their original state. Essentially, they are artificial muscles, except they operate silently and can be far more efficient than their biological counterparts. Their application could revolutionize robotics, allowing us to build soft, flexible robots that look and move much more like living organisms. In medicine, they could be used to create active prosthetics or devices designed to assist a weakened heart. Furthermore, they can be fashioned into tactile displays, allowing users to physically feel the texture of an image or even clothing that actively changes its shape and density. Visual. A soft, octopus-like robot moves its tentacles, which are constructed from electroactive polymers. The concept of programmable matter, or claytronics, might sound like the most outlandish sci-fi idea yet. Picture a substance composed of millions of microscopic robots, known as atoms. Individually, each atom can move, link up with its neighbours, and share energy. Collectively, they form a unified whole, capable of adopting any shape on command, much like a dense swarm of bees. Need a wrench? Your smartphone simply sends a command, and a handful of this smart dust on your table rapidly assembles itself into the exact tool you require. Done with the task, the wrench instantly dissolves back into a formless heap. This represents the peak of customization and universality. While the full realization of this technology is still a ways off, millimeter-sized prototypes are already in existence. In the future, claytronics could completely revolutionize manufacturing, design, and the way we interact with our physical world. Remember graphene? Scientists have gone a step further and created its tin counterpart, stannanine. Theoretically, this material is a topological insulator. That means it only conducts electricity along its surface or edges, while its interior remains perfectly insulating. And here's the kicker. It can do this with 100% efficiency, meaning zero energy loss, and, most astonishingly, at room temperature. Currently, all known superconductors require cooling to extremely low, cryogenic temperatures, a process that is both expensive and complex. If the predicted properties of stannanine are confirmed in practice, it will spark a revolution in both energy and electronics. We would unlock loss-free power transmission lines, super-efficient, near-heatless computers, and entirely new types of quantum devices. This makes it one of the most promising materials currently under investigation. Visual animation, showing electrons moving freely along the edges of a stannanine sheet, followed by a futuristic city featuring bright, efficient power lines. Have you ever truly seen the colour black? Not dark grey, but the kind of black that looks like a void, a hole in space? Meet Vanta Black. It's not a simple paint, but rather a substance composed of vertically aligned carbon nanotubes. This material can absorb 99.965% of all incident light. When light strikes the surface, it becomes trapped within this nanoscale forest of tubes and is virtually never reflected back. Consequently, our brains fail to perceive the shape or relief of the Vantablack coated object. It appears instead as a flat, two-dimensional void, a true absence of reality. The effect is mesmerizing, sometimes even slightly unsettling. Practical applications range from calibrating sensitive telescopes and creating more efficient solar panels to its undeniable use in military camouflage technology. Imagine a three-dimensional object, like a complex textured mask covered in Vanta black. As the object rotates, its contours and depth vanish completely, leaving only the perception of a featureless, flat, black shape. Diamond has long been the gold standard for hardness, but it finally has a challenger. Say hello to amorphous silicon carbide. Scientists created this new material by subjecting tiny carbon spheres, known as fullerenes, to immense pressure and heat. The result is a material that is not only harder than diamond, but also significantly tougher, meaning it's far more resistant to breaking or shattering. While conventional diamond is incredibly hard, it is also quite brittle. Amorphous silicon carbide is free of this major drawback. Although it's currently only produced in very small quantities, the potential applications are breathtaking. These include drill bits and cutting tools that never go dull, ultra-durable coatings for engines, electronics, and even armor plating capable of handling colossal stress. It looks like the king of hardness is about to be dethroned. Visual. Imagine an animation where a blade made of this new material effortlessly slices through a diamond, which then shatters upon impact, while the blade remains perfectly intact. We're used to thinking of electronics as something rigid and fragile, but flexible electronics are completely changing that notion. Instead of rigid silicon boards, circuits are now printed onto flexible substrates like plastic or even fabric. This is paving the way for entirely new categories of devices. Imagine a smartphone you can roll up and slip into your pocket, or a massive display that unrolls like wallpaper. But perhaps the most exciting application involves integration with the human body itself. Think of electronic tattoos that track vital signs, smart contact lenses that project information directly onto the retina, or clothing embedded with sensors and displays. The line between human and machine is becoming increasingly blurred, and flexible electronics are playing a pivotal role in this transformation. Visual. A person unrolls a tablet as flexible as a newspaper. Then, a close-up shot of a glowing electronic tattoo on an arm displaying the pulse. If you thought aerogel was the ultimate definition of lightness, think again. Meet aerographite. It is a synthetic foam composed of a lattice structure of carbon tubes. Aerographite is several times lighter than aerogel and ranks among the lightest materials ever created. It is so light, it practically floats, barely settling in the air. But, despite its minimal density, aerographite is remarkably strong for its weight, highly elastic, and, unlike many aerogels, it is an excellent conductor of electricity. These combined properties make it an ideal candidate for manufacturing lighter, higher capacity batteries. For example, using aerographite electrodes could drastically reduce the weight of power cells needed for electric vehicles and smartphones. Beyond power storage, it can also be used as a super-absorbent sponge for cleaning up oil spills, as it effectively soaks up petroleum products while completely repelling water. Visualization. A tiny piece of black aerographite rests perfectly on a dandelion head without crushing it, followed by an animation showing the structure of a battery utilizing aerographite electrodes. Graphene, aerogel, metamaterials, self-healing concrete. We've seen that the future isn't just about new gadgets or faster internet speeds. It's about the fundamental building blocks our world will be constructed from materials that repair themselves to substances that can render objects invisible. Science is opening up truly limitless possibilities. These 20 materials are truly just the tip of the iceberg. They will change everything: medicine, energy, construction, and space exploration. Perhaps even right now, in some laboratory, the 21st material is being created, one that will solve the problem of hunger or global warming. What an incredible time to be alive. Thank you so much for watching this video until the very end. If you found this as interesting as we did, Please hit the like button and subscribe to the channel so you don't miss out on new, incredible discoveries. And don't forget to ring that notification bell. Now we have a question for you. Which of these materials impressed you the most? And which one do you think we will see in our everyday lives first? Let us know your thoughts in the comments below. Let's discuss.